So we ended yesterday doing a couple of weird examples like limit as you approach negative infinity of e to the x and a sine to the x. I want to continue talking about these limits as we approach infinity and try to figure out, like, can we figure out what some of these things are equal to? If I wanted the limit as x approaches infinity of x cubed, what do you think that would be?
Infinity.
Infinity. If you plugged it in, if you take a really big number and cube it, don't you still get a really big number? Probably. If you think about the graph of x cubed, the chair, as you travel towards infinity on your x-axis, where's your y going?
Negative infinity. Oh, well, positive.
Positive infinity, so it kind of makes sense.
I was cooking the next one.
B, if you put in a negative, okay, if you cube a really big number, it's still a really big number, but if you take a negative to the third, it is
Still a very little bitty number.
a little bitty number. It's going to negative infinity. And we could, again, get that from the graph. So if you're just taking infinity to a power, it's still infinity.
So
Just watch your process.
show for this.
Not really. We're just kind of, this lesson is a lot of reasoning.
This is my kind of lesson.
Oh.
Yes.
Oh, Lord.
Okay, but here's where we run into issues. Can we do infinity squared minus infinity?
No.
Infinity.
No. Could we do like infinity squared plus infinity?
Mm-hmm.
If you add really big numbers, you get
Really
a really big number. If we subtract really big numbers, do we know what we get? Not necessarily. If you multiply two really big numbers,
You get a big number.
you get a big number. So infinity times infinity would still be infinity. But do we know that when we divide it?
No.
No. So addition and multiplication we can just work through. Subtraction and division we can't.
Take an X out?
Okay, what if we took an x out?
That's a good question.
So that would be x times x minus 1. Okay. If I plug in infinity,
No, multiply.
we're multiplying. What happens if you take a huge number and subtract 1?
It's still the white
Oh, a very huge number, man.
So a really big number times a really big number is,
Extra
Really
big number.
Squared.
which is, we're saying
Okay.
infinity. Okay, so we know that if we multiply big numbers, we get a big number. If we add big numbers, we get a big number.
Yeah.
All right, but does it work if I just say I'm dividing big numbers?
No.
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 Not quite.
What was the strategy we used yesterday?
Conjugate. But
Simplify.
that's not right.
Oh, yeah, we did.
By
do
1
the
half.
conjugate.
1 over X.
Yeah.
Okay,
What
we
do?
took everything times 1 over.
X. Oh, I'm not on the right page. I was like, where is this example?
So most of the time we do the highest power of x. So let's look at that. If we just, the highest power here is actually x squared, isn't it? If we did 1 over x squared. Okay, so we get x squared over x squared, which is 1, minus x over x squared would be 1 over x. 3 over x squared minus 1 over x. Are you guys with me here?
And then you can just plug that bad boy infinity guy in there.
We know that a number over infinity turns into 0, but what's wrong?
You can't have a 0 on the
We
bottom.
can't have 0 on the bottom. So this one got us because my highest power of x was on the top of the fraction. Yesterday it was always on the bottom. That's why we were able to do it. So we got here, but can we solve this?
No, that's not. No.
Okay. So let's try something different then. Seems like a solid strategy, except I got zeros on the bottom.
Can we multiply by negative like x negative 2?
That's the same.
How is
X
it
to the
still?
negative 2 is 1 over x squared. So let's just back it off the power and see if that helps. We would get x squared over x is x, minus x over x is 1, 3 over x minus 1. So you get infinity minus 1. 3 over infinity is 0, minus 1. Okay.
Wait, so
If it's a number over infinity, because remember our pizzas, we have a pizza. We invite more and more and more people in.
So we have more pizza.
Okay. What happens if you take a really big number and subtract one?
Big number.
Big number divided by a negative.
So it's a negative big number.
I like that we don't call it infinity anymore.
It's a big number.
Big number.
Big number.
That's the only thing it can be.
All right.
Quiz question. Oh, sketch.
All right. I want to do a couple sample quiz questions. Quiz questions.
I feel like that's only
I'm actually going to skip example 12.
Yay!
Because in the coming sections we'll do more stuff that would help with that type of problem.
That's
so
a
I'm
quiz
just going to skip
question?
it. Could be.
What?
Can we group?
I'm the
Yes,
last
we
one.
can.
How are we supposed
Wow.
to know that we're not supposed to multiply that one of those?
You try it and you get 0 on the bottom and it didn't work. So that's why we backed it off.
So we gotta do the cube. Or we can do this.
So what would we do here, do you think?
Do the square.
1 over x squared.
1 over x.
So I told you to do 1 over the highest power of x yesterday, right?
But we learned.
We just had one problem where it didn't work.
Oh, but we'll have a 5 left.
But yesterday we had several problems where it did, right? The reason it didn't just work out on this last
There
problem
was nothing else left.
is because the degree on top was higher than the bottom. In this problem, we have an x cubed on both top and bottom. So I think we're okay to go with that. Well,
She knows.
so we're going to take top and bottom times 1 over x cubed. So if we distribute that, we get 1 over x cubed. X squared over x cubed will be 1 over x. 2x cubed divided by x cubed is 2. On the bottom, x cubed over x cubed is 1. Minus 5x squared divided by x cubed is 5 over x. Minus 3 over x squared minus 5 over x cubed. I'm not showing as much work as I did yesterday. Are you guys with me here?
Oh, perfectly good.
So now we know a number over infinity turns into
0.
0, 0 plus 2 over 1 minus 0 minus 0 minus 0. So we get
2.
Oh my gosh, it's not infinity or 0.
Oh my gosh, it's 2. That's crazy. Crazy, pal. Very crazy.
all right. Grab a textbook. I'm going to do a problem out of the book next.
What?
Ouch, my
Yeah,
hand.
I'll pass them all out.
Does anyone smell like
Can you share with a friend?
I do smell that.
My hands are covered in pumpkin.
Sorry.
Like I washed them and everything, and they're just, I'm literally full.
That was the plan. I planned that.
I like that Cooper's not allergic anymore because I can actually use like
Oh,
indulge.
All right, page 140, question number 9. You might have one like this on your homework, so I wanted to look at one.
And then just prick my ears up a little bit.
What? The homework. Homework, you mean? Sure.
Thank you, someone listens to me.
It's on the board too.
Yeah.
No, I know. I was paying
Okay.
attention though.
So
Watch it, pal.
we are trying to draw a graph that would meet these conditions. So if I'm just asking you to sketch a graph that meets the conditions, do you think there's only one possible answer?
Nah.
No, but you are giving me one option. So f of 0 equals 3. What does that mean?
When x is 0, y
That's
is
0,
3.
that's 3. Yeah.
Okay, check, I've got that.
Checks directly in the book.
Don't you dare.
I won't. I would never.
The limit as x approaches 0 from the left of our function is equal to 4. Okay, so as I'm approaching 0, that's over here, it's coming into 4. Can I put another closed closed circle here?
No.
No, so this would have to be open. Now, I don't really know what it's doing yet. I need to go back and figure that out. But somewhere it's coming into 4. Now, I might have to adjust this, okay? It's not finalized yet. As we approach 0 from the right, it is equal to 2. So as I'm coming in from the right, it's going to 2. So that would have to be, again, an open circle because it's a function, as has the vertical line test. Okay, do I know that my little dashed lines are accurate whatsoever?
No.
No. But so far, does my graph meet all the requirements? Yes. Adjusting as we go.
So why do we know that it's an open circle and not a closed
Because we have a closed
Okay.
already, it can't fit the function.
All right, the next requirement. The limit as x approaches negative infinity is negative infinity. So as I go forever in the negative direction, my graph has to be going down. So I need to switch it. It's actually decreasing. Okay. The limit as we approach 4 from the left is negative infinity. So what's going on at 4?
Asymptote.
We would have a vertical asymptote at 4. As I'm coming in from the left, it's going to negative infinity. So this end is going down.
Isn't this no longer a function? Oh, vertical line.
Okay, the next limit as we approach 4 from the right is positive infinity. So as I'm coming in from this way, it's going up forever. Okay, and the last requirement, limit as we approach positive infinity, is 3. What's that?
A horizontal asymptote.
Horizontal asymptote at 3.
Would it only apply to that one?
Because it's only one direction.
Whoa.
It's crazy, man.
So uncooked.
So, on these, you are not just going to be able to read all the requirements and magically draw a graph. You need to do what I was doing. Each step, I fixed my graph to meet those requirements. And, sometimes I had to go back and change it. I might have been going up and my graph should have been going down. So we can tweak that as we go along.
So when x is approaching infinity, or negative infinity, that's when we have a horizontal asymptote, and when it's f of x is approaching negative infinity, we have that.
Other questions? Okay. I need you to get some paper to work on. We are going to look at a handout that I posted on Google Classroom.
Yay.
For some reason, I forgot you said that to me yesterday, and I was like,
This now.
okay.
So, we want to evaluate the following limits. Now we know with our limits, like if we get stuck, what option do we have?
Multiply by the opposite.
We've tried all these algebra techniques. We know worst case scenario, we can always go back to a table of values, but that's not very efficient. So we want to try to get away from that if we can. So if I give you this one, we would always check first to see, can you just plug in 6?
No.
No. If you do, you get,
36 minus 24 minus 12.
so we get 0 on the bottom. So we are not able to just plug in 6. So what strategy did we use in the past?
Factor.
You are writing your limit on every step.
That's 6 from the right. It is 6 from
Okay, what happens now?
Cancel the difference, and you get a hole.
So there is a hole, so a removable discontinuity.
I don't know if we need to know that right
Okay, can I plug in my 6?
now. No.
Okay, but here's where we're going to start being smart. We're going to think, okay? We're going to be smarter,
Oh, okay, thank you.
okay? So I can't just plug in 6, but I am approaching 6 from the right. Okay, so it means
You plug in 7?
we have 1 over, I am putting in something bigger than 6. So 7, 6.5, 6.4,
It's
6.1.
approaching infinity.
If I do 7 minus 6, 6.5 minus 6, 6.1 minus 6, what is that approaching?
0.
0. Okay, but would you agree? Okay, if I plug in 6, I'm going to get 0, but since I'm putting in things bigger than 6, all of those numbers are positives. Because I'm putting in something bigger than 6 and then subtracting 6. So I am approaching 0, but from the positive direction. Is everybody okay with me here? Okay. So, if you divide two positive numbers, what kind of answer are we going to get? A positive. Now we have to figure out what that answer is. So, I have one pizza, okay? And I start kicking people out of my class. What's happening to the amount of pizza each of you get?
It's getting
Well,
bigger.
Getting more, right? As I kick people out, there's less of us to eat it, so we all get more pizza. So 1 over 0 is approaching
Positive infinity.
positive infinity. Now,
Sorry,
I
that's
was
how math
only
works.
able to do that because I was approaching from the positive side only. If it had been two sides, it wouldn't have worked because one would be positive and one would be negative.
This is anarchy.
Yes, it would.
Swear.
All right. So, the same question, but now approaching it from the left. So you would still, try, be hopeful, factoring and reducing would make a difference, but it doesn't. So we have limit as we approach 6 from the left of 1 over x minus 6. So we have 1 over, you're putting in something smaller than 6 and subtracting 6. So it's getting closer to 0, but all those numbers are negative. So 1 divided by a smaller and smaller negative number goes to negative infinity. Now, if you don't like thinking in terms of pizzas, which I don't know why you wouldn't,
No,
but
can't really
you
use
could
that.
totally go back to making your table. If you're approaching 0 from the negative side, you're putting in negative 0.1, negative 0.01, negative 0.001. What is 1 divided by negative 0.1?
10.
110.
Negative 10. 1 divided by negative 0.01.
Negative 100.
1 divided by negative 0.001.
Negative 1000.
So, that gives us another way of seeing this is going to negative infinity. Alright.
I have a question about 3 then.
So number 3, the exact same question from both sides. We just found out
Does not exist.
6 is like a vertical asymptote. When you're coming in from the right, your graph's going to infinity. When you're coming in from the left, it's going to negative infinity. So does the overall limit exist? No, the left and right have to match for the limit to exist.
Ooh, I can cook it.
Absolute value means piecewise.
Yes, but I actually don't even have to do the full piecewise here
Because it's bigger than
because I am approaching 0 from the right. So the number I'm putting in is positive. If you put in a positive number, does absolute value change it?
No. It's
No,
just
so-
a line.
It's just x divided by x.
Which is 1.
So the limit as x approaches 0 from the right of 1, and the limit of a constant is the constant. So that one is still 1. Again, the only reason I was able to just rewrite it without the absolute value is because I knew I was putting in a positive number. All right. If you are approaching from the left, so it's a negative number. The absolute value of a negative number,
Positive.
so it's the opposite of what I put in. So that's the limit as x approaches 0 from the left of negative 1, which is
Negative.
Why would we put negative?
Why?
Why wouldn't it be a positive?
because x is a negative number.
Because you have to keep the
Oh,
property
it's
of the number.
positive on the top and it's negative as
Yeah.
the regular X on top is negative, and the one absolute side is positive.
Think about if you actually put in a number. So we're approaching from the left, so it's a negative number, right? So if you put in negative 0.5 divided by the absolute value of negative 0.5, get in negative 0.5 over positive 0.5, which is negative 1.
Oh,
Yeah, yeah.
But
just
wait,
put that negative on that.
Well, keep in mind, I say negative, but it really just means the opposite. So the opposite of a negative number is a positive number.
Yeah.
So you're just
She
doing the
got you there,
absolute
right?
value.
She's just trying to trick you.
You're just getting rid of the bar.
Yes.
Trying to trick you. Ah.
Okay.
Why did you sound rich there for a second?
If I factor, does anything cancel out here?
No.
No.
not at all.
Okay. So the top, as I'm approaching 7 from the right, I'm just getting 7. On the bottom, 49 minus 49 is 0, but I'm putting in a number bigger than 7. So if it's
Positive 0 or 0 plus, which just means
be approaching 0 from the right, because my number is bigger than 7, so when I square it, it's bigger than 49. Do we agree with that? Okay, so I have 7 pizzas to feed the school. Walk into the cafeteria and buy 7 pizzas at lunchtime. And I start kicking out everybody that's ever made me mad. So what's happening to the amount of pizza you get?
More.
Getting bigger and then
Bigger and bigger and bigger.
Yeah, the whole class is going.
And so we get positive infinity.
So,
Only if the top were like a negative 7, then that would work.
so anytime it's 0 positive, then it's infinity, 0 negative is.
If the number on top is positive. I'm thinking of it as I have a positive number divided by a positive, so I get a positive answer.
Okay.
If this had been a negative over positive would be a negative.
That's still like fraction, correlate to the thing, like.
The top is like number of pizzas, bottom is number of students.
Oh, so the divided by is the people.
Uh-huh.
Pizza, pizza.
I just like that. Please, can we only talk in pizza analogy? When the
Just talk in terms of pizzas.
When the expert is here, he's gonna be so confused if we don't ignore.
He's gonna be like, this calculus teacher has no idea what she's talking about. All she can do is talk about pizza.
She must be so hungry. They just have lunch.
Alright. If I look at this one. So nothing cancels. If I put in 7 on top, I get 7. Okay, 7 minus 7 is 0, right?
Yeah.
And I'm approaching 7 from both sides, so its number is bigger than 7 and smaller than 7. But I'm squaring it. So what kind of number will it turn out to be?
Positive.
So 7 divided by 0 from the right would give me,
Infinity.
okay,
We're so good.
Wait,
Wait,
so
don't
what?
go on. Yeah, right now.
Oh, cause
I know,
wait.
hang on. You already have it. X plus 2.
What about the negative side?
There is no negative sign.
It's
Okay.
positive and squared.
Right, I'm saying like,
You formulate your numbers before you square it.
oh yeah, my bad, that's on the top, that's on.
All right.
the
All right.
Pizza.
Wait, no, but what if the top is bigger?
alright, so are we okay on problem 7? Do you have a question first?
She already told
I
Sarah
was
about
just thinking like, what if it's a negative number?
Well, we know we're approaching 7, so you're getting closer and closer to 7. So like 6.9, 6.99, 7.1, 7.01, so they're positive.
But if they're positive,
Yeah,
it's
no,
like a
I-
negative X.
Yeah, but if it was like, I was
Okay.
thinking as if it was 0, yeah.
This one, I can't factor and reduce. If I put in a 3 on top, 3 plus 2 is 5. On the bottom, 3 minus 3 is 0. But I'm not approaching it from any one side. So you have to think, okay, if I'm approaching 3 from the left, that's smaller than 3. And so when I subtract 3, I'm approaching 0 from the negative side, right? But if I put in something bigger than 3 and subtract 3, I'm getting a positive. So does this work?
No.
No. From one side, it will be a negative. From the other side, it would be a positive. So we can't evaluate this one. They don't match. The reason the others worked and this one didn't is they were from one side only. The previous problem was from one side, but we squared it, which made it positive no matter what.
Yeah.
This one, if you think about the graph of it, it's as you come in from less than 3, it's going to be going to negative infinity, and bigger than 3 is going to positive infinity, so they don't match up. All right, number 9, everybody try that one. See if you can figure out what that would be.
Well, I can attest that does not sound legit.
So, what do you think this one is?
5 over 0 plus, which makes it infinity.
Yes. Very good.
That'd be,
All right, last
No, I didn't want you to scroll down.
problem
Wait.
Of
the
Let
day.
me write it.
I didn't want you to scroll down.
Good job.
Oh no, dude.
I ran out of space. Oh, I put it
Right.
back though. I'm not gonna do it.
Every
I
time I
said
think it's only gonna get worse.
It's not
Oh,
bad.
stop. It's not bad.
Oh, it is worse though. Oh, wait, no, it's not.
So we could do this a couple different ways. We could draw a picture. We've graphed piecewise functions before. I made you draw the graph and evaluate them. We could do it without a graph as well. If you are approaching from the negative side, are you less than 3 or greater than 3?
Less than.
If x is less than 3, am I on the first piece or the second piece?
First piece.
So its limit as we approach 3 from the left of x squared minus 5. Okay, the left doesn't matter anymore. That's what told me which piece I'm on, so I could just plug in a 3. And we get
4. Oh yeah. Now one equals 5. So that one does not exist.
alright, is everyone okay on part A?
Yep.
Part B, I want the limit as we approach 3 from the right. So from the right means greater than 3. If you're greater than 3, you are on the second piece. So if we plug in a 3, 3 plus 2 is 5.
5.
C wants the overall limit. In order for this to exist, the left and right have to match, do they?
No.
Does not exist.
So is this any different from the stuff we did before? Or is that just like a review?
I was just having you do it without the graph this time. In the past, we drew the graph and looked at it, which you could certainly still do. All right. Any questions there? So at this point, we've got some time left now. Tomorrow, you guys leave
After this walk.
Okay, so you will be here tomorrow. Tomorrow is a work day. So the book problems are due Monday.
Oh yeah. Monday.
You have class now and the entire class tomorrow to work on this. Problem number 13, it says to justify each step by indicating